All right, let's talk about AI prompts. If you've ever felt like you're just kind of shouting words into the void and hoping the AI gives you something good back, you are definitely not alone. But what if there was a way to stop guessing? A way to turn those vague ideas into rock-solid, valuable assets every single time? Well, that's exactly what we're going to break down. It really comes down to this one question, doesn't it? When you're using AI for serious work, is it a trusty tool you can depend on, or is it a ticking time bomb? Because when those prompts are unpredictable, that line gets blurry fast. And believe me, a mistake can be more than just a little embarrassing. $100 billion. That's how much Alphabet's market cap dropped after a single bad answer from its Google Bard AI during a demo. It's just a crazy reminder of how high the stakes really are. And here's the scale of the problem we're up against. When researchers really push these large language models with tricky questions, they can hallucinate, which is a fancy way of saying they just make stuff up, a whopping 82% of the time. That is a massive gap between what we want and what we're getting. So, what's the name for this problem? It's called prompt fragility. It basically means that a tiny, innocent-looking change in your prompt can cause a huge, unpredictable swing in the AI's output. It's the root cause of all these headaches and costly errors. So how in the world do we fix this? Well, it's all about a shift in mindset. We have to stop thinking of writing prompts as some kind of creative art form and start treating it like a proper science. It's not magic, it's engineering. And that engineering mindset has a name. We're about to introduce a framework that helps us move away from the world of chance and into a world of certainty. Meet the Kernel Framework. It's a set of 6 core principles, a true playbook for designing prompts that are tough, reliable, and actually perform well. And this didn't just come out of nowhere. It was developed by digging into over 1,000 real-world prompts to see what really, truly works. So here's the breakdown. Kernel is an acronym, and each letter is a rule. You have to keep it simple. The output needs to be easy to verify. You need reproducible results. Your prompt should have a narrow scope, give the AI explicit constraints, and follow a logical structure. Simple as that. And does it actually work? Oh yeah, the results are pretty staggering. Just by applying the kernel framework, the success rate on the very first try jumps from 72% all the way up to 94%. Think about that. That's the difference between messing around all day and just getting it right the first time. But hold on, it gets even better. We're not just talking about getting an answer on the first try, we're talking about getting the right answer. When you adopt this kind of structured approach, you can see accuracy shoot up by over 300%. That's just a game changer. Okay, so having a great framework is one thing, but how do you actually put it to work? Well, there's a super clear 3-phase process that's designed to take a huge pile of prompts and sift through them until you're left with pure gold. The process is really logical. First, you clean your data. Get rid of all the junk and duplicates. Second, you assess the quality of what's left using some really strict rules. And finally, you classify the absolute best of the best as your high-value assets. Phase 1 is all about focus. You've got to clear out the noise. In the study we're looking at, that meant finding and deleting any prompts that were more than 80% similar to each other. They cut 44 duplicates right off the bat, which let them focus their energy on the prompts that were actually unique and had real potential. So, once everything is nice and clean, we get to the most important part, the assessment. This is where we draw a line in the sand between prompts that are just kinda useful and the ones that are truly exceptional. This whole assessment leads to 2 main categories. You've got your S-tier prompts, these are the gold standard, the absolute best of the best. Then you have A-tier prompts. They're still good, still useful, but they're missing some of those key kernel principles, like explicit instructions or a really logical flow. So what does it take to get that S-tier ranking? It's got to meet 3 non-negotiable criteria. 1, it has to be super specific with crystal clear instructions. 2, it has to solve a real, valuable problem. And 3, it has to save a ton of time. We're talking 30 minutes or more every time you use it. Okay, enough theory. Let's look at a real-world example of how this engineering approach can take a pretty average prompt and turn it into something you can actually build a workflow around. Here we go. This is a classic A-tier prompt. I bet you've written something like this before. Generate some ideas. It's fine, you'll get some stuff back. But it's so vague. It leaves way too much open to interpretation, which makes it a perfect example of prompt fragility. But we can do so much better. By applying those kernel principles we talked about, we can take this flimsy request and forge it into a precise, powerful instruction. And here it is, the S-tier version. Look at the difference. We gave the AI a specific role, act as a technical specialist. We narrowed the scope from just ideas to a full-blown strategy. And we added an explicit constraint for the output. It has to be in JSON-LD. This isn't a suggestion anymore. It's a command. So after putting an entire library of prompts through this whole process, what was the final count? Well, the results speak for themselves. Out of hundreds of prompts, only 3, just 3, made it to S tier. Those are the real production-ready assets. Another 8 were solid A tiers, good but needing a little more work. It's all about finding the critical few.
So if you remember one thing from all this, let it be this. If you want reliable, top-tier results from your AI, you absolutely have to treat your prompts with the same seriousness and discipline that a software engineer treats their code.
And what does that mean in practice? It means you test them. You test them systematically before you ever let them near an important workflow. You see how they behave with different creativity settings, what's called temperature. You stress test them with all kinds of different inputs to make sure they don't break under pressure.
And all of this leads us to one final big question for you to think about. We live in a world where our words can control these incredibly powerful AI systems. So if prompts really are the new code, are you just messing around like a hobbyist, or are you building them like an engineer?